Hello, Ms. Nocher. How are you?
Thanks, I'm fine.
How is the new car?
It's really good so far, but I'm not satisfied with the consumption. The figures in the leaflet are not at all the same as the actual consumption. I don't know, but I need at least 2 liters more.
Do you know this? Do you know what you have to do in this kind of situation? No? This isn't a problem, because in our current product information, we do not only talk about how these consumption and CO2 figures come about, but also how to deal with this kind of customer complaint. And at this point, welcome to Volkswagen TV. And welcome to our guest in the studio, Dr. Klaus Rode-Brandenburger.
Hello.
Very often customers complain that the consumption of their vehicle is too high. They also often want a replacement of their vehicle because they think that the manufacturer information in the sales documents isn't correct. What do you think of this kind of complaint? You have dealt with consumption and CO2 figures for a long time now.
We are familiar with this kind of situation. I have to say that in Europe, the official consumption and CO2 figures for vehicles are determined by using a standardized test procedure. It's valid all over Europe for all manufacturers. This is the only way the customer can compare the figures of different vehicles and of vehicles from different manufacturers. But the consumption of the customer includes many other factors. This means that the consumption may differ by a factor of 2. As a result, this official manufacturer information can't predict the individual consumption of the customer. What's more, you have to tell the customer that the urban and interurban figures are different, and they must not only consider the combined value.
The value is determined by using the NEDC. What does NEDC mean?
NEDC is the abbreviation for New European Driving Cycle. This cycle prescribes exact driving rules that have to be adhered to when the vehicle is tested on the dynamometer.
Does the new European driving cycle only apply to passenger cars or to commercial vehicles as well?
It applies to passenger cars and commercial vehicles with a gross vehicle weight of up to 3.5 tons. It doesn't apply to vehicles with a gross vehicle weight of more than 3.5 tons.
Before determining the consumption and CO2 figures, you first have to fix the vehicle on a single axle roller dynamometer.
When the vehicle has been fixed on a single axle roller dynamometer, a fan is placed in front of the vehicle. It cools the engine of the vehicle during the driving cycle. Then the oil dipstick is replaced by a special dipstick with temperature sensor. By using it, you can check whether the vehicle has been conditioned to the room temperature of 20 to 30 degrees Celsius. After grates have been put up to protect the wheels, a screen is placed close to the driver. It will show the speed that the driver has to keep during the cycle. In the measuring room, all data is entered that is necessary for the measurement. Before the driving cycle starts, the oil dipstick has to be replaced again. An extraction hose has to be put on the exhaust pipe of the exhaust system, and the fan has to be switched on.
You talked about exact driving cycles. What do they look like?
You can see the new European driving cycle on this diagram here. It indicates a driving rule with the speed on the vertical axis and the time on the horizontal axis. It includes 2 sections. Firstly, the urban section, which simulates urban traffic, up to a speed of about 50 kilometers per hour. Then there is the interurban section, covering about 7 kilometers. Here, the maximum speed is 120 kilometers per hour. There are individual figures for the 2 sections. Firstly, urban operation, and secondly, interurban operation, and the combined value is the whole consumption covering 11 kilometers.
So, to be able to compare the figures of different vehicles, you have to adhere to the driving cycle.
After the cycle has been started, the driver exactly follows the course on the screen. The speed and the gear are predefined for a very specific time. All accelerating and braking procedures have to be adhered to, otherwise the figures can't be compared. In the measuring room, the whole cycle is recorded and then analyzed.
This kind of test on a single axle roller dynamometer takes about 20 minutes. Is it possible to consider all kinds of driving situations?
No, this isn't possible because this driving cycle takes only 20 minutes and has a length of 11 kilometers. During this cycle, the urban and interurban consumption values are determined. The average speed of the urban cycle is only 18 kilometers per hour, and of the interurban cycle, about 60 kilometers per hour. If the speed of the customer differs from the figures, and if they drive more dynamically or faster, they will probably have higher consumption. So we know that the average consumption value of the customer is higher than the combined consumption value. If we look at the individual values and compare the urban values with the interurban values, we can see that the urban figures are always much higher than the combined value, and the interurban value is lower than the combined value. So if the customer considers these values, they should know that, depending on the driving profile, higher consumption may occur.
But the customer often just considers the combined value. It's especially highlighted. It's printed in bold type. Why is it printed in bold type?
I think the reason is that this value is the basis for taxation of the vehicle and for calculating the European fleet emission value for all vehicles, which is necessary to comply with the legislation. The urban and interurban figures are not used for this purpose, and I think this is the reason why they aren't highlighted in the leaflet.
But they are important to the customer.
Yes, they are important to the customer. These three values indicate that there will be different consumption values depending on the driving profile. But they are also useful to be able to compare vehicles from different manufacturers or vehicles of different power categories.
Let's talk again about the initial situation. The customer comes into the workshop and talks to the service advisor. They complain about fuel consumption that is too high from their point of view. What should the service advisor do?
First of all, you have to make sure that there is no technical defect. You have to read out the fault memory and, if necessary, carry out an emission test. If there is no technical defect, you should tell the customer more about influencing variables and how these variables might influence the consumption of the customer.
You can't foresee how much fuel is consumed by the customer. The figures in the documents can only be used to compare vehicles. There are many variables that have an influence on the individual consumption. We have simulated it with the Charan as an example. For a fuel consumption of 6.5 liters, what do you have to do?
Our test driver drives on a predefined course with moderate driving style, anticipatory with low rotational speed. So this is how customers should drive their vehicles.
A consumption of 7.1 liters is also possible.
Yes, here 4 additional persons enter the vehicle. The test person will drive with the same driving style and on the same course, but because of the excess weight, the consumption is about 7.1 liters per 100 kilometers.
So this is quite obvious. More weight means more effort. But aerodynamics is an important factor too.
Yes, here our driver has attached a loaded roof box to the vehicle. There are two variables here. Firstly, the weight that increases the consumption, and secondly, the higher aerodynamic resistance. As a result, there is a consumption of 8 liters per 100 kilometers.
Quite different variables lead to a consumption of 7.5 liters.
Here, the driver has switched several consumers on. These might be the air conditioning system, ventilator, navigation device, seat heating, and rear window heating. Then the consumption rises to 7.5 liters per 100 kilometers.
Yes, if all the consumers are switched on, they have to be supplied with energy. If there is a consumption of 9 liters, it's not the fault of the driver, is it?
This is again driving with the loaded roof box. For example, when going on holiday. If there is stop-and-go traffic, you have to stop and start very often, and this leads to a consumption of 9 liters per 100 kilometers.
But these haven't been all the influencing variables.
No, in addition to the number of persons, excess weight, activated consumers and traffic flow, there are other variables that have a strong influence on the consumption. These are distance, speed, gear selection, whether I drive with low rotational speed or high rotational speed, dynamics, whether I have an anticipatory driving style, and of course the outside temperature has a strong influence on the individual consumption. Each of these variables can have a significant effect on the consumption. It's not possible to include all these variables in the NEDC.
Let's have a look at the consumption of a Golf, 1.4 liters, 90 kilowatts as an example. What can we see here?
We can see the NEDC again, but the diagram has a different axis. That is, the horizontal axis is not the time, but the distance. At the beginning, we can see the urban cycle with a length of 4 kilometers. We can see that the consumption is very high at the beginning, but is reduced gradually, until the value 8.2 for urban areas has been reached. The fact that it starts with such a high value does not depend on the vehicle type. That's because of the starting process. Then, 7 kilometers are covered in the interurban area. The result is a consumption of 5.1 liters, and the combined value is 6.2 liters per 100 kilometers, covering the whole distance of 11 kilometers. You can see on the diagram that the manufacturer provides a consumption range that is by 32% higher than the combined value or by 18% lower. So the whole range is 50%, and you can see that the distance has a strong influence on the consumption. If this Golf is predominantly used for driving to the kindergarten, where the distance is only 2 kilometers, the customer might have an average consumption of 10 liters per 100 kilometers, even though there is no technical defect.
Customers often don't consider this. Let's have a look at the film with the driver of a T5. What can you see?
We can see the situation that has just been explained. The driver is starting the vehicle. It's still not moving. On the consumption gauge, you can just see some lines, because indicating a very high consumption value wouldn't make much sense. At a distance of at least 300 meters, the consumption is indicated, and you can see how the final value is calculated after traveling a certain distance.
In addition to the distance, speed, gear selection and dynamics have been mentioned as influencing variables on the fuel consumption. We are going to show you how these variables influence the consumption with the help of 2 test persons. The first test person drives very calmly in a high gear to the motorway. He has an anticipatory driving style. He doesn't accelerate when approaching traffic lights that turn to red and lets the car coast. The driving behavior is adapted to the surroundings. He drives calmly onto the motorway. On the motorway, he keeps a moderate speed. And he reacts very early to new traffic conditions. The second test person goes into the curve in a quite different way, in a low gear, and he speeds up even when approaching red light. It's the same on the approach road and on the motorway. He speeds up even though he knows that he has to brake soon. He doesn't have an anticipatory driving style. He doesn't adapt his driving behavior to the traffic conditions. You have seen the two test persons and differing driving behavior. What do you think? What is the difference in the consumption?
You might guess that the consumption of the second test person is much higher. This depends on the gear selection, on the high speed level that is used, on the high speed, and on the very dynamic driving style. Our tests have revealed that on the same course, the consumption may rise by 25 to 30% because of a different driving style.
As an additional variable, you have mentioned the outside temperature. Does it have a strong influence on the fuel consumption?
The NEDC is measured in a range of 20 to 30 degrees Celsius. These ideal starting temperatures occur rarely when the customer wants to drive to work in the morning. So on this diagram, you can see how the consumption may change depending on the temperature and distance. The upper line shows the highest consumption. The temperature range is -9 to -5 degrees Celsius. And the lowest consumption is here below, in a temperature range of 11 to 15 degrees Celsius.
How did you measure it?
These values were measured on a 27-kilometer-long route, in the morning when driving to work. Different vehicles were used for the measurement. The starting temperature and the average consumption values on the route were listed. Then the values were divided into 5-degree intervals, and the average values were calculated. And this measurement revealed that when driving between 1 and 5 degrees Celsius, the NEDC combined value was reached after about 10 kilometers. Therefore, we have set this value to 100% on the diagram. It's interesting that the relative figures on this diagram, the figures in percent, also apply to CI vehicles, so not only to SI engines. And you can see clearly that the temperature has a strong influence. At a distance of 10 kilometers, a change in temperature of about 20 degrees Celsius means that the consumption increases by 20%. And you can also see that the consumption is very high when the engine is started, and then it falls steadily. And you can also tell the customer that if they drive very short distances, only 5 kilometers when driving to work for instance, they will never reach the NEDC combined value.
Why do these huge differences occur?
There are several reasons. Firstly, a cold engine consumes more fuel than an engine at operating temperature. But there is also loss. Friction in the gearbox, in the drive shafts, in the wheel bearings, and the tire rolling resistance rises sharply. And this leads to higher fuel consumption. What's more, the air density rises in the winter at cold temperatures, and this leads to higher consumption because of the higher aerodynamic resistance.
So this means a standardized consumption cycle like the NEDC can't cover all influencing variables. The consumption is already different when considering the different seasons.
Yes, as we have seen, there is a consumption difference between summer and winter of 20%, and if the different driving styles are considered too, there might be differences of 40 to 50%.
The amount of fuel that is consumed by a vehicle depends on many influencing variables. You have dealt with this topic for a very long time now. You certainly have some advice how to reduce fuel consumption.
Firstly, I can just repeat the information that you are familiar with. Don't take unnecessary load with you. Use a moderate driving style. Don't drive so fast and dynamically, otherwise you would lose energy when braking. But most people know this advice. I would say it like this. If you drive on your route with moderate speed, in the highest gear possible, and try to brake as little as possible, you will have perfect conditions and the lowest consumption possible for this route.
So selecting the correct gear is important, and we have simulated it on the roller dynamometer. What was the result?
Here we can see a vehicle on the roller dynamometer. It's driving at a constant speed of about 50 kilometers per hour in the third gear. The rotational speed is about 2,000 revolutions per minute, and the consumption is 5 to 5.1 liters per 100 kilometers. Now, the driver is going to switch to the fifth gear and will drive at the same speed of 50 kilometers per hour in the fifth gear. The result is that the rotational speed falls to just above 1,000 revolutions, and the consumption falls to 4.1 liters per 100 kilometers.
If many customers complain about something, in our case they say that consumption is too high, it's also a topic for the media. What do they say in magazines, on TV or the internet?
On the internet, we can often see customer forums in which the customers write down their fuel consumption. In test magazines and in test reports on TV, we can often see test consumption figures, and you can see that the same vehicles that are tested by different magazines have different test results. But if you look at all the results, you'll see that most of the figures can be found in the manufacturer's information leaflet as well. Of course, you have to consider the difference between urban and interurban figures. In my experience, the individual consumption values of about 80% of all car drivers are within this range. Nevertheless, there will always be drivers that aren't within this range, even though there is no technical defect. The driver's influence on the consumption is very often ignored in test magazines or the media.
How big can the difference between two extreme drivers, as I call them, be?
In my experience, there might be a difference of 25 to 40%, depending on the driving profile. If there are also different distances, speed values, or other variables, the values of two customers may differ by the factor of 2. Nevertheless, you have to tell the customer that there is the urban and interurban range, because most of the customers will be within this range.
The NEDC only applies to the European area. Outside Europe, there are only two other defined test cycles, one in Japan and another one in the USA. The test cycle in the USA is often considered to be more realistic. Is it true?
Let me explain it. The approach is different in the USA. In the USA, there are various figures. Firstly, the figures that have to comply with the consumption legislation, and secondly, the consumption values that the customer can see in the showroom. In Germany, the consumption figures from the legislative test procedure are also used for the showroom. This is done differently in the USA. If you did the same in the USA as in Germany, that you use the figures from the legislative approval procedure for the showroom, the consumption values would be much lower.
How come that the consumption values are lower than here?
The consumption cycle in the USA is quite similar to the one in Europe because there is a city and a highway cycle. But the city cycle is much longer than the urban part in Europe. This means the operating distance with warm engine is much longer. The distance with cold engine is much shorter. They also drive at a higher speed, up to 80 km per hour in the last gear, whereas the maximum speed of the urban cycle in the NEDC is only 50 km per hour in the third gear. And the longer distance and the longer time with an engine at operating temperature lead to the fact that the consumption values are lower. The same applies to the highway cycle. It started at operating temperature, and the maximum speed is just 90 km per hour in the last gear.
So much slower than in the NEDC. But if the values are lower, why are they considered to be more realistic?
I'll show you that on this diagram. We used a 1.4-litre SI vehicle for the calculations. In the NEDC, the vehicle has these values. You can also see the values of the American approval procedure that have to comply with the consumption legislation. So, these values here. Here you can see that the consumption value is about 10% lower if it was used for customer information as well. But you don't do that in the USA. Until 2007, a correction factor was used for the US approval values to calculate the values for the customer information leaflet. So the results were values that are about 6% higher than the ones in the NEDC. Since model year 2008, additional cycles with air conditioning system, high speed and low temperatures have been introduced. And these new cycles, as well as new weighting factors, lead to a higher consumption value of 7.5 litres. And this consumption figure is 21% higher than the consumption value in the European showroom.
Especially the combined value is quite important to the customer. We have already mentioned it. But what about weighting factors?
In Europe, we don't have weighting factors. We just use natural weighting factors. That is 4 kilometers to 7 kilometers. So 36% urban traffic and 64% interurban traffic. In the USA, fixed weighting factors are used, regardless of the length of the cycles. These are 55% for urban traffic and 45% for interurban traffic. If we used these weighting factors for the NEDC, we would have a value for the customer that is 10% higher.
These have been a lot of information. I'll sum it up. Correction values and additional cycles with complicated weighting formulas seem to offer more realistic consumption figures in the system of the USA. In Europe, the consumption figures that are measured in the new European driving cycle are used for the customer information leaflet as well. But the values for the customer information leaflets in the USA are higher due to additional cycles and weighting factors. In this current product information, you have received a lot of information that may help you when talking to the customer who complains about too high fuel consumption. Let's summarize. What does the service advisor have to do when a customer is complaining about things like that?
The service advisor should arrange an appointment for checking the vehicle. You should take the customer home in their car, and the customers should drive the car themselves.
And the service advisor should pay attention to the driving behavior of the customer. What do staff have to consider especially?
They should pay attention to the driver's speed, which gears they choose, whether they drive with high or low rotational speed, the way they accelerate, whether they have a rapid or moderate driving style, how often do they use the brake, do they brake hard or do they have an anticipatory driving style and brake gently. You should also pay attention to special features such as traffic lights and traffic flow. and ask the customers about what the special features of their routes are, for example, the distance.
Then the technical check is carried out on the vehicle. What does it look like?
Normally, you start with the visual check. You also check the tire pressure. If necessary, you have to carry out an emission check. The fault memory has to be read out. And you can check whether the brakes work properly. Then you have to check whether accessories have been mounted, for example, sports tires that are especially wide, which may cause additional consumption. If you can't see any failure, you shouldn't carry out any other steps.
Then we have seen that the driving habits of the customer may cause higher consumption. It's quite difficult to tell somebody that they have to change their habits. What is the best way to do that?
I would suggest that the service advisor picks the customer up from home again. But this time, the advisor should drive the car. You should stick to an anticipatory driving style and use the advice that we have just explained. Then you can tell the customer carefully what you have noticed. You could start with, "I noticed that," so you can tell them politely how their driving style may influence the consumption.
And should the service advisor explain the difference between the realistic fuel consumption and the NEDC figures?
Yes, definitely. The service advisor should make clear that the NEDC figures are used to make comparison possible, and they can't predict the individual consumption of the customer. What's more, the advisor should also tell the customer that there are differences between urban and interurban figures, and that the NEDC is started at a temperature of 20 to 30 degrees Celsius. Normally, the temperature is lower, and this leads to higher consumption. And you should explain that the maximum speed of the urban value in the NEDC is 50 kilometers per hour, and of the interurban value, 120 kilometers per hour. And you should say that surroundings and traffic may have an influence too. All these variables, as well as the individual driving style of the customer, may lead to a consumption that is twice as high as the NEDC figures.
So the fuel consumption depends on many variables. These are the driving style, of course, but also the traffic conditions, surroundings, as well as the loading condition of a passenger car or commercial vehicle. These have been a lot of information for you. I think we provided you with a lot of information for your next customer talk. Thank you, Dr. Rode-Brandenburger.
My pleasure, and I wish you success with this current product information.
And I say goodbye, see you next time.